Silicon has been around long enough. It's time for a younger and far more fit challenger to take over semiconductor material dominance. Gallium nitride power devices are smaller, faster, more reliable, and comparably priced. At this point, there are a few reasons not to use GaN FETs and ICs. The GaN Talk podcast is a series of interviews with the people behind the rise of gallium nitride in power electronics. This interview-style podcast series talks to the visionaries, leaders, researchers, and engineers using gallium nitride to disrupt the power electronics industry.
Welcome and thank you for joining us on the GaN Talk podcast, where we will speak with Bel Lazar, CEO of EPC Space, to answer the question, why GaN in space? Bel Lazar is CEO of EPC Space. Bel also serves as COO of Efficient Power Conversion. Prior to joining EPC Space, Bel was CEO of API Technologies, now Spectrum Control. Prior to that, Bel worked for Microsemi, now Microchip, and ran the high-rail business unit at International Rectifier, which is now Infineon. Bel earned an MS in electrical engineering from California State University Northridge, and Bel also holds a JD in law from the Southwestern University School of Law. Welcome to the GaN Talk podcast, Bel.
Thank you, Rick. Glad to be here.
So, Bel, tell us about EPC Space, the mission, and the products.
Yes, so EPC Space was formed in 2020, March 2020, in the middle of the pandemic. And EPC Space is a joint venture between EPC and VPT. And as you know, Rick, EPC is the largest producer of GaN on silicon power devices and dominates the under 400 volt market, while VPT is a global leader in providing power conversion solution for high reliability applications. EPC Space is focused on designing and manufacturing radiation-hardened GaN on silicon transistors and ICs, packaged, tested, and qualified for satellites and other high reliability applications. EPC Space is the world's only company that is dedicated for power GaN devices for space applications. And EPC Space is located in the greater Boston area in Massachusetts.
Interesting. So Bel, what is radiation-hardened gallium nitride, and can it displace rad-hard silicon in spaceborne applications?
Yeah, I mean, I'll talk a little bit more about how it can displace it, but in general, EPC's rad-hard GaN is designed by EPC's engineer to have a guaranteed radiation hardness for both what we call total ionizing dose and single event effects. EPC's eGaN HEMT is superior to rad-hard silicon in every aspect. So let's just pick one aspect. The key difference between an eGaN HEMT and a silicon MOSFET is their figure of merit, which is defined as the product of the on resistance, or RDS on, and the input gate charge, which is QG. For similarly rated rad-hard devices, let's say 100 volt, 30 amps, a typical rad-hard MOSFET figure of merit is 2.9, while an equivalent eGaN HEMT in EPC Space product portfolio is 0.17, both in the same units. So the lower the figure of merit, the easier it is to drive a device for a given on-state resistance. As you can see, GaN is superior to silicon.
Interesting. So another question that gets asked a lot is, what does the supply chain look like? And what's the lead time situation and the competitive position for EPC Space in the market?
Yeah, I mean, all of EPC Space's eGaN HEMT come from EPC Corp. Then EPC Space packages these HEMT devices and screens and qualifies them to a MIL-PERF 19500 JNS requirements. Our current lead times are about under 15 weeks for space and under 5 weeks for developmental units. Now, yeah, and EPC Space has two major product lines, discretes and modules. The modules include rad-hard drivers and power stages. Rad-hard integrated circuits will be launched in 2024.
Okay. So a question that often gets asked too, obviously in space, is heritage. You know, space heritage. We hear this term a lot, space heritage. EPC Space and rad-hard GaN space heritage. Can you comment on that?
Yeah, actually, before I do, actually, I neglected to mention the market size. We estimate the rad-hard FET and drivers market to be about $200 million, give or take, per year. With our current product offering between EPC and EPC Space, we can address about 40% of this market. But our goal is to get to 80%, addressing the 80% of this market in about 2 to 3 years. Going back to your heritage question, space heritage to some and probably to most customers is a testament of your product reliability. Now, our product have proven reliability and have heritage, and so many customers want to see evidence of space heritage before ordering. And for those customers, we have over 150K of GaN HEMT devices in orbit, both in LEO and GEO orbits.
That's interesting. So space heritage is important. The lead time situation sounds very competitive. What else can you tell us about EPC Space and the developments that are going on with the company? Are you growing the company, or you said you're located in Boston, I believe, in the Boston area?
In the greater Boston area. So we, when we started in March 2020, we were about 7 people. Right now, we're about 25 people, and we're hiring. We can't hire enough people to keep up with the demand. We have a very efficient manufacturing process, and we do all the manufacturing post the wave fabrication and the supply chain from EPC. All the manufacturing and qualification for space level quality levels is done in Andover, Massachusetts, which is in the suburbs of Boston. And so we expect and we've been doubling our business, tripling our business in the last couple of years. We expect to have a similar growth rate to address up to 80% of the market. Now, when I say 80%, we're not going to be able to address the P-channel market on this rad-hard FETs market, but we can address everything else. And with our ICs, and what we're doing is we're integrating our devices to offer ICs, rad-hard ICs, which we will launch, as I said, in 2024.
That's very interesting. Well, Bel, I want to thank you for taking the time to join us today on the GaN Talk podcast. I know our listeners and our viewers will find this very, very interesting. And I know you actually have a show coming up that you're going to be going to, the Radex show, which is in Toulouse, France later. And good luck at that show with EPC Space.
Thank you, Rick, and thank you for your time. It was always a pleasure. Thank you. Take care.
Thanks, Bel.
All right, bye-bye.